Welcome back to Tiny Teeth Talk, the study channel for dental students and residents. Hit subscribe and the bell icon to stay updated with every new videos. Now let's jump in. Today we are continuing our series with nitrous oxide sedation part 4. We will be doing a deep dive into the nitrous oxide delivery system in detail with its whole assembly, how to use and connect, etc. So main components of nitrous oxide delivery system are breathing circuit, flowmeter assembly, regulator, pressure gauge and cylinders. And this delivery system can be of two types, centralized system or portable system. In portable there is a flowmeter, cylinders mounted on the yoke with pressure gauges and regulator, breathing circuit and scavenging. Here cylinders manifold with the pressure gauge and regulator, gas outlets, flow meter, breathing circuit and scavenging pump, passive scavenging. So a certified medical gas plumber must be contracted for installation of a certified gas copper piping system because it is a centralized delivery system. If you see these part in the nitrous oxide delivery system, then this is called flow meter assembly. It is a main part of the nitrous oxide delivery system which help in regulating the flow and concentration of gases being delivered to the child. So first is flow meter tube. This is nitrous oxide flow meter tube and this is oxygen flow meter tube. It provides visual reading on the flow rate of gases. It consists of color coded glass tube for oxygen and nitrous oxide with ball floats for flow rate indication. Blue color is indicated for nitrous oxide and green is for the oxygen. And here there is a ball which float for flow rate indication. Fail safe. It prevents delivery of nitrous oxide in the absence of oxygen. Here there is a valve which is basically a fail safe. You can see here is the fail safe valve. Here is nitrous oxide supply. The nitrous oxide travel through these to here, which is breathing outlet, and this is the oxygen pipeline. How this mechanism work, how this is fail safe. The nitrous oxide line is physically blocked by a spring loaded valve. The valve can only be held open by a pressure exerted by the oxygen supply. If the oxygen pressure drops below a self threshold, which is 30 psi, the pressure is no longer strong enough to hold the nitrous oxide gate open. The spring snaps the valve shut, instantly stopping the flow of nitrous oxide. If you turn out of oxygen, the machine ensures the patient only breathes room air via the emergency air intake rather than pure nitrous oxide. So this emergency air intake we'll discuss later. Then flow adjustment knob. The knob helps in adjusting flow rate of gases without altering nitrous oxide or oxygen concentration. So this is the flow adjustment knob. It increases or decreases the total amount of gas sent to the patient's lung. If you have the machine set 50% nitrous oxide and 50% oxygen, you turn the flow adjustment knob up, the machine will give the patient more gas, but it will be exactly half and half. Why? Because you adjust this to match patient's lung capacity. A small child might only need 3 to 4 liter per minute while the adult might need 6 to 8 liter. When you turn these, both the oxygen and nitrous oxide floats in the glass tube will move up or down together. It changes the total volume of the gas patients breathe every minute but keeps the percentage exactly the same. Then concentration control valve. Okay, this nitrous oxide flow control valve is a concentration control valve, and here there is a percentage of nitrous oxide return. So concentration control valve, this knob regulates the desired titration concentration of one of the gases. It changes the ratio strength of the sedation without changing how much air is flowing. So if the patient is breathing 6 liter per minute, you turn this knob from 30% nitrous oxide to 40% nitrous oxide. The total flow stays at exactly 6 liter. The machine automatically reduces the oxygen slightly to make room for an extra nitrous oxide. This is what used for titration. When you turn these, the float moves in opposite directions. If you increase the nitrous oxide, the oxygen float will automatically drop a bit to make a room. This keeps the total volume of gas flowing to the patient steady so they don't feel a sudden change in pressure. Then emergency air valve. So this is the emergency air valve. It allows patient to inhale ambient air in case of the flow gas is interrupted. This is a small one-way flapper valve usually located on the top side of the flow meter, as I already shown you. As long as the machine is pushing gas into breathing bag, the pressure keeps the emergency door pushed shut. The moment the pressure from the machine drop to zero, the patient's own breathing creates a tiny bit of suction, and this suction pulls the emergency valve open, and the patient can now pull in a regular room air, which is ambient air, through that valve. The emergency air valve is like an emergency window that pops open if the machine stops giving the patient gas. The patient is wearing a mask that fits snugly over the nose. They are getting all the air from the tubes connected to the machine. If both the oxygen and nitrous oxide tanks run out, or if the machine has a mechanical failure, the patient wouldn't be able to breathe at all because the mask is sealed. So they would feel like they are suffocating. So that's why this come into the picture. Why this is vital in the pediatric dentistry? So children can panic very quickly if they can't catch their breath. So first, safety. It ensures that even if the equipment fails completely, the child never airs out. Then room air. While room air only has 21% oxygen compared to the 30% or 100% machine gives, it is enough to keep the child safe until you remove the mask. So in short, it is a suction activated door that lets the child breathe the air in the room if the machine's gas supply fails. Then non-rebreathing check valve. Here is non-rebreathing check valve. It prevents inhaling of used gas. A one-way door located inside the breathing circuit that ensures gas only flow in one direction towards the patient. So why do we need it? So when a child breathes, they inhale and exhale. Okay, so without this valve, if this valve is not there, the child would breathe out their used air, which is full of carbon dioxide, back into the same tube they just breathed from. When they take their next breath, they would breathe that garbage air back in. But with this valve, the valve is thin flexible disc. When the child breathes in, the disc flips open to let fresh oxygen and nitrous oxide in. When they breathe out, the disc slams shut, forcing the used air out through a separate exhaust port, which is the scavenging system. So why it is critical in pediatric clinic? So it prevents carbon dioxide buildup. If a child rebreathes their own air, their carbon dioxide level rise, and this can make them feel dizzy, nauseous, and given them a headache. Then fresher sedation. It ensures that every single breath the child takes has the exact recipe of nitrous oxide and oxygen you set on the machine, not a dilute version mixed with old breath. Then safety. It keeps the reservoir bag, which is the balloon on the machine, filled with only pure fresh air. Then oxygen flush button. Here is the oxygen flush button. It provides extra delivery of oxygen. It helps to deliver 100% oxygen, overriding all other gas flows. Normally, oxygen and nitrous oxide go through the flowmeter and knobs where they are mixed. When you press it, this oxygen flush button, oxygen bypasses all the mixing valves and knobs. It delivers a massive blast of 100% pure oxygen at a very high flow rate. It instantly fills the reservoir bag and the patient mask with pure oxygen, washing away any nitrous oxide that was there. So when a pediatric dentist uses it, the wake up call. At the end of the procedure, you need to flush the nitrous oxide out of the child's lung to prevent them from feeling dizzy, which is diffusion hypoxia, I've already discussed. You hit the flush button to fill the bag with 100% oxygen quickly. Then in emergency situation, if a child's become too deeply sedated, for example, they stop responding or their breathing becomes shallow, you hit this button to instantly give them a higher concentration of pure oxygen. Then filling the bag. If you just turn the machine on and the reservoir bag is flat, you hit the flush button to fill it up in 1 second so child has enough air to breathe immediately. When you press the button, the machine says stop everything else, give 100% oxygen right now. That's why it's called overrides. It doesn't matter if your concentration knob is set to 50% nitrous, or it doesn't matter if your flow knob is set to low. As long as your finger is on that button, the patient is getting pure high pressure oxygen. In short, it is a high pressure reset button that clears out the sedation and fills the child lungs with 100% fresh oxygen instantly. Then on off switch. That is the on off switch which prevent the accidental delivery of gases. So this on off switch is the master lock for the entire sedation units. It's main job is to ensure that no gas can leak or be accidentally delivered when the machine is not in use. Then bag T assembly. So here the bag T outlet. So this part in front of flow meter helps to connect the flow meter to the reservoir bag and the corrugated hose and circuit. Emergency air inlet and non-breathing check valve are also a part of bag T assembly. Then the reservoir bag. This helps to maintain a reservoir of gases from which a child patient can inhale. It is however not required with modern circuits like the silhouette mask. So this is the reservoir bag and this is the modern silhouette mask. How it works. The machine constantly pumps out a steady stream of gas. However, the humans don't breathe at a steady rate. We inhale quickly and then pause. So the bag collect the gas while the patient is pausing or exhaling. When the patient take a deep breath in, they pull the extra gas from this bag so they don't feel like they are sucking through a thin straw. It is also used in monitoring. It is a vital visual tool. You watch the bag expand and contract to see how deeply and quickly the child is breathing. Then this is the silhouette mask. It is a low profile disposable nasal mask often used in a modern pediatric dentistry. These circuits are designed to be a high flow or more open. They often use in a different type of tubing that doesn't rely on a large rubber bag or gas. Direct delivery. Instead of holding tank, the gas is delivered more directly because the mask is smaller and less bulky. It stays out of the dentist way while they work on the upper front teeth. Also, they do the scavenging. The silhouette system is very efficient at sucking away exhaled gas immediately, which reduces the need for the traditional rebreathing or reservoir setup. Then oxygen inlet. This is the oxygen male part. So it comprises the male component of DISS system. It is the specific entry point on the back of the flow meter head where the oxygen hose connects. So DISS stands for Diameter Index Safety System. It is a genius safety design used in a medical equipment to prevent accidental gas mix-up. So it is basically the lock and key logic. Every gas has a different size connector. The oxygen inlet has a specific diameter and thread pattern that is different from the nitrous oxide inlet. The male component. So on the back of your portable analog unit, you will see a threaded brush or metal peg sticking out. This is the male part. The safety result, because the sizes are different, it is physically impossible to screw a nitrous oxide hose onto the oxygen inlet. This ensures you never accidentally give a patient 100% nitrous oxide when you think you are giving 100% oxygen. And nitrous oxide inlet, it comprises a male component of DISS system. So this is the nitrous oxide inlet male component. So in busy pediatric clinic, equipment is often moved or hose are replaced. So this DISS system is your silent partner in safety. Even if a staff member is in hurry, they cannot cross connect the gases because the threads simply won't fit. Okay, now let's see flow meter accessories. First is positive pressure resuscitation or oxygen dimmed valve. So this is a high level emergency tool that turns your sedation unit into a life saving ventilator. How it works? It's a specialized mask and valve set that connect to the quick connect port on the side of the Potter or matrix head. So this is the quick connect port. For non-breathing patients, you press a trigger with your index finger to force 100% oxygen into the lungs. It has a built-in alarm that whistles if the airway is blocked. So if the child's airway is blocked, the pressure will build up. A safety relief valve will open and the device will make a loud whistling sound. This tells you immediately that the air is not reaching the lungs and you need to reposition the head or clear the airway immediately. So for breathing patients, if a child is struggling to breathe, the valve opens only when they attempt to inhale, providing a high volume boost to 100% oxygen exactly when they need. The moment the patient creates even a tiny bit of a suction by trying to inhale, the valve snaps open and delivers a high volume of 100% oxygen. So the benefit is this makes it much easier for a weak or struggling patient to get the oxygen they need without having to work as hard to pull it through a long tube. Then this is inline vacuum control. It is a safety tool that protects everyone in the room. So we have to must connect it with our delivery system. So in your dental office, the flow meter gives gas to the patient, but the vacuum kit's job is to scavenge the gas the patient exhales so that you and your assistant do not breathe in. So you must use it during every single sedation procedure. How to use it? So first is the physical setup. The kit sits between your vacuum source source and the patient mask. Here is your high evacuation vacuum system. Suction basically you use. Then this is the in vacuum control kit, and this is between the mask and the vacuum system. Bottom part connects to your clinical's wall suction, a high vacuum evacuation or dedicated scavenger pod, and then top part connects to the thin scavenging hose coming off the back of the patient's nasal mask. Here you can connect, which is a thin hose. Now turning it on, push the gray toggle switch on the side of the block on the on position. You will hear the sound of suction. These on button you have to press. Then setting the green zone. So look at the glass tube. You will see a small black ball float. Twist the adjustment knob on the side of the block until the ball is floating right in a green bar area. You have to twist these so this black ball float into this green area, and you have to twist it until this black ball float into this green area. So these confirm the flow of exactly 45 liters per minute. This is the gold standard for safety. Then the AVS automatic vacuum switch machine, it's connect here. So it is a safety critical component that ensures scavenging occurs automatically whenever nitrous oxide is being delivered. These AVS work based on pressure sensing. So it wakes up as soon as it detects gas flow from the flow meter, which is typically 1.5 to 3.5 liter per minute. It did the automatic scavenging. Once the gas flows, the internal diaphragm opens the vacuum line. This means you don't have to remember to turn on the suction manually. Auto shut off. When you turn off the flow meter at the end of the procedure, the AVS automatically closes the vacuum line. This prevents your central suction from being drained by the unit that isn't in use. So AVS act as a middleman between your flow meter, the patient's mask, and your office vacuum. So how to do step-by-step installation? So ensure the rubber washer is inside the nulled nut. Screw the AVS onto the flow meter outlet until tight, and it should not rotate. Screw your back T assembly onto the AVS outlet. Here you can connect it. Then connect this back T assembly to the AVS machine. Connect the vacuum hose from the vac pot on the AVS to your operatory suction. So you have to connect this vac pot to your operatory suction. Then plug the scavenging tubing from your breathing circuit to the mask pot. Then turn on the oxygen flow. Look at the sight glass, the acrylic tube with the ball float on the side of AVS. Adjust the control knob until the ball float in the green zone, which is calibrated 45 liter per minute per NIOSH guidelines. Now, nitrous oxide delivery system categorized into two main technologies, analog and digital. So, analog flow meter, they use two glass tubes containing ball floats. The height of ball indicates the liter per minute of the gas flowing. So, the mounting style is trolley mount, portable. The unit is on the stand with the wheels and can be moved between operatories. Then, cabinet or wall mount, fixed, offers a sleek profile that saves floor space. Then under the counter, so tucks away under the dental cabinetry for a minimalist look. Then digital flow meter. So digital flow meter replaces the glass tubes with the electronic displays and push button controls. Instead of tubing knobs, you use up and down arrow keys. This is up and down arrow keys to set the flow rate or change the concentration. It changes usually in 5% increments. It has a 4 critical alarms as a safety. So digital units offer a high level of safety through automated audio visual alerts that analog units cannot provide. First is oxygen failure. So on screen they display the liter per minute and percent oxygen will usually go blank or show a flashing O2 fail or low O2 message. The nitrous oxide numerical display will drop to 0 immediately. Then if nitrous failure, then nitrous oxide side of the screen will flash nitrous oxide fail or low nitrous oxide. The oxygen display will stay active, but the nitrous oxide display will show 0.01 lpm. Then oxygen limit, if you try to turn the oxygen down too low, a message like 1 lpm limit or minimum oxygen will scroll across the screen. Then flush flow low, when you press the oxygen flush button, the emergency button to fill the reservoir bag with 100% oxygen, the screen might flash flush low or low press. Both the oxygen failure and nitrous failure are self-cancelling alarm. When the gas is restored, the unit returns to the flow rate and mixture ratio which were in effect before the alarm condition. Then breathing circuits. Breathing circuits involve the rubber tubing which deliver gases from the flow meter to the patient and removes the exhaled gas. So 22 mm right angle connector. So this is the 22 mm right angle connector that connects the back T assembly to the corrugated hose. Then corrugated hose, this connects with a Y connector to the coaxial tubing. This is the Y connector. Coaxial tubing. So these are the set of two tubes which runs parallel to each other. One tube carries only inhaled air and the other carries only exhaled air. So there is no mixing of inhaled and exhaled air. Then hood assembly. It consists of the nasal hood with inner liners or a nasal hood with the exhalation flap valve. Then nasal hood. Nasal hood can be of various type. First is single use. This is a single use. This avoids any cross contamination and saves times of dental auxiliaries. Then scented or unscented. This can be used based on the person liking children. So nowadays kids dental introduce a scented pen which will apply on the inner side of the mask. Then low profile nasal hood. It provides easier access and better visibility. Then contoured design. It will have an outer rigid mask with the inner soft disposable liner. The kind of mask is very effective for scavenging purpose, thereby reducing the ambient air concentration of nitrous oxide. So it has a two-layer architecture. The inner soft liner, which is disposable. It is usually soft, scented, translucent silicone or plastic. Then function. This sits directly on the child's nose because it is soft and contoured. It creates a tight seal against the skin, preventing nitrous oxide from leaking out in the room. And it is disposed of after every patient to prevent cross contamination. Then outer rigid mask, which is reusable. It is a harder clear plastic shell. It sits over the inner mask. There is a small space between the inner liner and the outer shell. The patients breathe nitrous oxide or oxygen mixture from the inner mask. When the patient exhales, the waste gas leave the inner mask. If any gas leaks past the seal of the inner mask, it immediately trapped by the outer rigid mask. The vacuum hose constantly pulls the air from the space between two masks. Without this design, every time a child cries, talks or mask shifts, nitrous oxide leaks into operatory and you and your assistant breathe that all day. And with this design, the outer mask sucks the leakage away into the central suction system, and this keeps the ambient concentration of nitrous oxide within the NIOSH recommend limits, which is 25 ppm. Basically, this describes a double mask scavenging system which is currently the gold standard for safety in the pediatric dentistry. And when you read about a contoured design with an outer rigid mask and inner soft disposable liner, it is describing a mask within a mask architecture. Here the seal is everything. If the soft liner isn't contoured correctly to the patient's face, the scavenging system has to work twice as hard. A good tip is to have the patient adjust the mask themselves to find the most comfortable airtight fit. The nasal hoods are available in different sizes such as a small, medium and large. Now minimum oxygen liter flow. So nitrous oxide oxygen delivery system are designed to provide the minimum oxygen flow of 2.5 to 3 liter per minute. These safety features ensure that the child has access 100% oxygen as soon as the machine is turned on. So the moment you turn on the machine, the oxygen flow automatically jump to 2.5 to 3 liter per minute. The machine will not allow you to set the oxygen flow to zero. Even if you don't touch the knobs or buttons, the patient is guaranteed a base layer of life sustaining oxygen. If a child is anxious or struggling, you can place the mask on them immediately, knowing they are getting pure fresh oxygen before you even being titrating the nitrous oxide. Then minimal oxygen percentage. This is one safety feature which enables this device to deliver at least 30% oxygen at any given time, which is more than the ambient air oxygen of 21%. This happens when the nitrous oxide concentration is 70%, and usually concentration of nitrous oxide being delivered is 35 to 50%, which means oxygen concentration being inhaled by a child is 50 to 65%. Then maintenance and calibration. Maintenance schedule should be followed strictly. It helps to ensure that the equipment is functioning smoothly and flawlessly. So daily checks. All the connections are securely attached and functioning properly. Inspecting the tubing and other parts of visible cracks or tears because it can leak the gas. Check for the cleanliness around the cylinder, because we already discussed that dirt or metal or chipping of color or dust can react with the gas and cause leakage or do the chemical reaction or block the valve, etc. Then check the functioning of fail safe device with the concentration knob and flow control knob both in working. Close the flow control knob to 0. This should reduce the flow rate of both the gases to 0, although the concentration knob is not turned off. Another method is to move the concentration control knob 50% without turning on the flow control knob. On doing this, flow meter reading will not rise from 0. Then monthly checks. Check for the leakage on all the joints using soapy water solution. Check line pressure gauge and cylinder pressure gauge. Check functioning of the concentration control knob valve or calibration. So to check the calibration, there is a 50-50 calibration test. This is the most accurate way to see if the ratio is correct. So first turn on flow control knob to steady rate like 10 lpm. Turn the concentration knob to exactly 50%. Observe the ball floats in the glass tube. Both O2 and N2O balls should be at the 5 lpm mark because it is 50-50. So if one ball is at 6 and other is 4, your mixer is out of calibration and needs professional servicing. Then a full range sweep test. This checks if the concentration valve is sticking or has a leak at the extremes. So set the total volume 6 lpm. Turn the concentration knob to 0% nitrous oxide. O2 float should be 6 lpm because the nitrous oxide will be 0%. The nitrous float should be at the 0. Slowly turn the concentration knob towards 70%. First 6 lpm oxygen float because 0% nitrous oxide concentration knob. Then it raised to 70%. Watch the floats moves in opposite directions. As the nitrous oxide float rise, the O2 float must be dropped. If the O2 float stays while nitrous oxide rise, the auto compensation is broken. Then testing the fail safe. The concentration knob should never be able to deliver nitrous oxide if the oxygen source is gone. So set the mix to 30% nitrous oxide. Physically turn off the oxygen cylinder at the tank. Watch the oxygen float drop. The moment the oxygen float hits button, nitrous oxide float must also drop to 0 immediately, even though your concentration knob is still 30%. If nitrous oxide float stays up, the fail-safe valve has failed. Do not use the machine. Then to check the oxygen flush is working or not, for that oxygen flush test. So the flush is your emergency button to fill the lungs with 100% oxygen quickly. First, ensure unit is connected to oxygen source. Look at the reservoir bag. Press and hold the oxygen flush button. So what should happen? The bag should inflate rapidly. You should hear a loud hiss of high pressure gas. If the bags fill slowly or the flush flow low, alarm trips. Your central oxygen pressure is too low. Then to check non-breathing valve is working or not, this valve ensures the child does not breathe back in their exhaled CO2. So remove the nasal mask from the tubing. Place your mouth or a clean palm over the end of the breathing tube and try to blow the air back into the machine. What should happen? You should feel complete resistance. You should not be able to blow air back into the reservoir bag. If you can blow air back through the tube, the valve is stuck open. The child would end up re-breathing their own waste air. Then to check the emergency air inlet working or not. So how to check? First, turn off the all gas flow. Take a deep breath and try to inhale through the nasal mask. It stimulates a patient trying to breathe when the tanks are empty. So you should hear a click or hiss of room air entering the system through the emergency inlet, and the child should be able to breathe room air even if the machine is off. But if you feel like you are sucking through a sealed straw and cannot get air, the inlet is stuck, this is a major danger. Now disinfection. Disinfection of flow meter, breathing circuit, reservoir bag and vacuum control unit cannot be ignored, considering the most of them are rubber goods. So in nasal wood liner, it should be autoclaved or it should be discarded. Most modern silicone nasal hood are autoclavable. Check for the autoclave symbol. If they are disposable liner, discard after every single use. Breathing tubes, wipe with a quaternary ammonium disinfectant after every patient. Reservoir bag, wipe end of the day. day. So the bag is made of a thin latex or synthetic rubber. It is fragile and can crack if treated with the harsh chemicals. So mild soap and water or a non-alcohol based disinfectant should be used. Only wipe the exterior surface gently. Do not submerge the bag or the get liquid inside it. If moisture stays inside the bag, it can grow mold or fungus, which the next patient will then breathe in. If the bag looks sticky or has tiny cracks, replace it immediately. Then flowmeter, damp a vial with 70% isopropyl alcohol after every patient. In our next session, we will do a deep dive into the scavenging system and more. So stay tuned for that. To get the PDF for this video, any of our previous topics, simply like the video, subscribe the channel and drop a comment with the topic name and your email address. My team and I will send the materials directly to your inbox. Thank you for watching.